ISRO's LVM3 launches GSat-7, India's heaviest and Navy's most advanced communication satellite. The Indian Space Research Organization, ISRO, on Sunday, November 2, 2025, successfully launched the Indian Navy's Advanced Communication Satellite, GSat-7R, CMS-03, from the Satish Dhawan Space Center in Sriharikota. LVM-3, earlier referred to as Geosynchronous Launch Vehicle Mark III, or GSLV Mark III, gives ISRO launching capability to Geosynchronous Transfer Orbit, GTO. LVM-3 is capable of lifting 4-ton, 4,000 kilograms satellites to Geosynchronous Transfer Orbit, GTO, and 8-ton satellite to Lower Earth Orbit, LEO. LVM-3 is configured as a 3-stage vehicle with 2 solid strap-on motors, S200, 1 liquid core stage, L110, and a high-thrust cryogenic upper stage, C25. The S200 solid motor is among the largest solid boosters in the world, with 204 tons of solid propellant. The liquid L110 stage uses a twin liquid engine configuration with 115 tons of liquid propellant, while the C25 cryogenic upper stage is configured with the fully indigenous high-thrust cryogenic engine, CE20, with a propellant loading of 28 tons. The overall length of the vehicle is 43.5 meters, with a gross liftoff weight of 640 tons and a 5-meter diameter payload fairing. LVM-3 M5 rocket specifications: height 43.5 meters, vehicle diameter 4.0 meters, heat shield payload fairing diameter 5.0 meters, number of stages 3, liftoff mass 640 tons. Payload to GTO, Geosynchronous Transfer Orbit, 4,000 kilograms. LVM-3 will be capable of placing the 4-ton class satellites of the GSAT series into geosynchronous transfer orbits. Payload to ELEO, Low Earth Orbit, 8,000 kilograms. The powerful cryogenic stage of LVM-3 enables it to place heavy payloads into low Earth orbits of 600 kilometers altitude. 1. Cryogenic Upper Stage, C25. The C25 is powered by CE20 with propellant loading of 28.5 tons. It is India's largest cryogenic engine, designed and developed by the Liquid Propulsion Systems Center. 2. Solid Rocket Boosters, S200. LVM-3 uses 2 S200 solid rocket boosters to provide the huge amount of thrust required for liftoff. The S200 was developed at Vikram Sarabhai Space Center. The L110 liquid stage is powered by 2 Vikas engines designed and developed at the Liquid Propulsion Systems Center. Formal: GSat-7R, aka CMS-03. GSat-7R, also known as CMS-03, is an advanced multi-band communication satellite developed indigenously by the Indian Space Research Organization, ISRO, specifically for the Indian Navy. It is designed to provide secure voice, video, and data communication among the naval ships, submarines, aircraft, and maritime operations centers across the Indian Ocean region. Covering up to 2,000 kilometers from India's coastline, the satellite weighs about 4,400 kilograms, making it the heaviest communication satellite launched from India to a geosynchronous transfer orbit, GTO. GSAT-7R replaces the aging GSAT-7 satellite and supports multi-band UHF, S, C, and Q bands, communication with advanced payloads and indigenous components like a large propulsion tank and collapsible antenna systems. It has a planned mission life of 15 years. The satellite was launched on 2 November 2025 by ISRO's heavy-lift rocket LVM3 M5 from the Satish Dhawan Space Center, Sriharikota. GSAT-7R CMS-03 is primarily utilized to meet the advanced communication and strategic requirements of the Indian Navy, with several significant uses. Naval Communication Backbone acts as the primary satellite communications grid for the Indian Navy, enabling robust, secure, real-time voice, video, and data transmissions between warships, submarines, aircraft, and command centers across the Indian Ocean region. Wide regional coverage provides continuous encrypted communication over a footprint extending up to 2,000 kilometers from the Indian coastline, ensuring network-centric operations in remote and contested oceanic areas. Maritime domain awareness strengthens the Navy's maritime surveillance, fleet coordination, and threat assessment capabilities by supporting seamless information flow and coordinated responses during peacetime and conflicts. Strategic autonomy reduces India's dependency on foreign satellites for defense. Communication, promoting greater self-reliance, Atmanirbhar Bharat, in critical technological sectors. Support for civilian agencies. Besides its core defense role, it also aids civilian applications such as disaster response, remote sensing, and telemedicine through improved connectivity in remote maritime and coastal regions. Technological advancement future-proofs Indian maritime operations by integrating modern, indigenous payloads and enhancing secure, high-capacity bandwidth for evolving naval missions. GSAT-7R CMS-03 is primarily utilized to meet the advanced communication and strategic requirements of the Indian Navy, with several significant uses. Notable indigenous technologies. Propulsion tank, 1,200 liters for orbital maneuvers. Collapsible, large deployable antennas for efficient multi-band transmission. Digital processors, waveguides, designed for high data traffic and redundancy.